Welcome to this tutorial. Today I'm going to be solving this problem, which mainly involves an explanation on Kirchhoff current law and how to apply it. We're of course going to use Ohm's law as well. So let's get to it. This problem asks for the voltage V, which is labeled here, and for the power supplied by these two elements, which are of course current sources. So I'm going to apply Kirchhoff current law on this node right here, which I'm going to label M1 for the sake of rigorosity, I guess. So on N1, if I apply Kirchhoff's current law, I can take all incoming currents, add them up, and say that they're equal to 0, which is Kirchhoff current law. So the current going in here is -2 amps, and don't be afraid to use the sign here. That's just the current that is stated here. Now the current that is going in right here, it's negative I, of course, I1, as I1 is going out. So negative I1 is going in. Then we have -3 amps and negative I2. This should be equal to 0. Now notice that if I were to take the outgoing currents, I would get the same expression except multiplied times -1. And that makes no difference. So let us find what's the value in terms of other elements of I1 and I2. For this purpose, I'm going to use Ohm's law, which is voltage equals resistance times current. So let's just get I1. Since I1 is going down, I can place here the signs of our resistor. And we notice that it coincides with this V, which means that the voltage here and the voltage that we're going to use in here is also V. So if we isolate here I, we get that I equals V over R, and we can say then that I1 is equal to V over R, which is 10, and I2 is V over 6. With these two, I can rewrite this expression as follows. -2 minus I1, which is V over 10, minus 3 minus V over 6, and that should all be equal to 0. Now it's just a matter of algebra and doing things carefully. So let's just find V. 5 should be equal to, I carried these two to the other side, negative a tenth, and a sixth should be equal to, let me use my trustworthy calculator, 10th plus a sixth, 4/15. So 4 over 15V, which means that our voltage should be equal to 5 times 15 over 4 negative volts. And that means that V is equal to negative 18.75 V. Feel free to double check this result in case I made a mistake. But well, I found V already. Now we're gonna get the power supplied, and this is gonna be an easy task, but it does deserve some explanation. So let's just tackle these -2 amp current supply. Let me draw it right here. This is -2 amps, and we have here our V. Again, don't be afraid of this negative sign. We know that if we have an element here and a known element with a V here, we can say that this could also be represented with the opposite signs and a negative here. So don't be afraid of saying that this is a negative voltage. Let me just erase this real quick. There we go. No, it did not go. Nice. So then, for this, we need to take the sign of the pole through which the current is going in. So we know that the current is traveling this way. We take the negative sign. to use our passive sign convention and say that P equals negative VI. Okay. We know then that V is equal to negative, and excuse me for my bad handwriting, I'm making an effort, 18.75 V, and I should be equal to negative 2 amps. With this, P should be equal to negative 18.75 volts times negative 2 amps. And that's negative 37.5 watts. Now for the other element, I'm gonna be drawing it here. So we have a current going down. We have a voltage here, and this is a 3 amp source. Again, we take the sign for which the current is going in, which is positive, and we say P equals VI. Again, this sign right here is positive because of the of this pole, and we know that V again is negative 18.75 V, and that I is equal to 3 amps. And with this information, we can see that P is equal to V 75 volts times I, which is 3 amperes, and that's going to result in negative 56.25 watts. So these would be our two results. So worth mentioning, once again, it's very important that we consider the positive sign convention, which means that we're going to take as the sign of our expression or formula, whichever sign the pole through which the current is going into, regardless of the sign of the current. And also very important, well, we use the definition of power and the definition of Ohm's law. Feel free to ask me any question to my email, and or leave any comment below. Thanks.